Hello, we will discuss on the sex-linked recessive disorder. The first one is hemophilia or bleeder's disease. Hemophilia is a disease in which a person suffering from this disease bleeds profusely, even from a small cut, and may lead to death if unattended. Hemophilia is a sex-linked recessive disorders, and the gene for hemophilia occur in the X chromosome. And this hemophilia occur mostly in male because male have only one X chromosome. So in case of male, the sex chromosome are XY. So a person will become hemophilia if the gene for hemophilic, that is H, is in the X chromosome. So since male have only one X chromosome, male become hemophilic when this gene that is coding for hemophilia is present in the X. Here Y doesn't carry any gene for the hemophilia, so the male become hemophilic. In case of female, female have two type of sex chromosome, that is X and X type of sex chromosome. So in case of female, the female will become hemophilic when both the X sex chromosome have the gene for hemophilia. If there's two sex chromosome, that is X and X, if one have hemophilic gene but other is normal, then in that case the female become carrier, and this hemophilia is not expressed in this female. Now let's look at the cross. What will happen to the offspring if a hemophilic man marries a normal woman? So this is the sex chromosome of male and this is the sex chromosome of female. So XH and Y. I told you Y doesn't carry the gene for hemophilia, and it is the X chromosome that carry the gene for hemophilia. So in this case, in male, XH with Y means male is hemophilic, and female in this case normal means XX. They doesn't have any gene for hemophilia. So during gamete formation, the gamete will occur in this form, and the fusion of this will give rise to XH with X means this one with this will give rise to this. Y with normal X will give rise to the normal son. So in this case, if we look at the sex chromosome of the female and male offspring, the female in this case, one X is received from the male. So the hemophilic sex chromosome is received from the father, but the normal X chromosome is received from mother again. So I told you that in case of female, to become hemophilic, both X sex chromosome have to contain the gene for hemophilia. Then in this case, only one X chromosome is hemophilia, the other is normal. So in this case, the female offspring become the carrier. That means the hemophilic gene is not expressed in female, and the female is just a carrier. Now here, son receive the normal X chromosome from the normal woman and Y chromosome from the father. So in this case, all the sons that will be born by the crossing of the gametes of hemophilic man and the normal will become a normal son, and the female offspring will become a carrier. Now the next, when this what will be the result of the offspring when the carrier female marries the normal man? So this is the carrier female and this is the normal man. The gamete will be in this form, and one X chromosome is received from father and one hemophilic X chromosome is received from mother. So this will cross with this again, this Y will cross with this, and this will cross with this again. So in this case, there is one carrier female and one normal female, one hemophilic male and one normal son. In this case, if we look at the possible offspring, 50% of the female will be carrier, 50% of the female will be normal, 50% of the male offspring will be hemophilic, and 50% will be normal again. So this is the possible result of the offspring that may occur when normal man marries a hemophilic, or the carrier hemophilic women. Now the third is, what will be the result of the offspring if hemophilic women marries a normal man. I told you that women become hemophilic when hemophilic gene is present in both the XX sex chromosome. So this is the gene, this is the sex chromosome for hemophilic women, and this is the sex chromosome for the normal man. So during gamete formation, both the X chromosome having the hemophilic gene will occur. Here also X and Y normal X and Y sex chromosome. So the fusion of the gametes will give rise to X, 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 Y. So one X with hemophilic gene is received from mother, one normal X is received from father. So in this case, the female, this is female, the female become carrier. In this case, one X chromosome with hemophilic gene, one with Y, from the one sex chromosome, this is Y from father. So here the child become hemophilic, that is son. Here this will fuse, this is one, and it will give to the female, but this female will become carrier again. So this one will fuse with this one, and this will result in son, and this son will become hemophilic again. So in this by this clause, if we look at the sex of the offspring, then all the daughter will become carrier. That means 100%. There is 100% possibility that the resulting offspring will be, the resulting offspring of the female will be carrier, and there is also possible that 100% of the son that may result by the fusion of the gametes of the hemophilic women with normal man will result in hemophilic son. Now the next topic, let's discuss on colorblind. There are some persons who are unable to distinguish certain colors. So those person are called as colorblind person. Several types of colorblindness are known, but red and green colorblindness are also called as daltonism, named after the scientist named Dalton. This colorblind, this is a sex-linked recessive disorders, and the gene for colorblindness is also present in the X chromosome. So what will happen if the normal woman marries a colorblind man? So this is the colorblind man. I told you that the gene for the colorblind is present in the X sex chromosome. So in case of men will become colorblind if X gene carry the X chromosome carry the gene for colorblind. So this is the colorblind man, and this is the normal women. When they enter into intermarriage, this is the gametes, these are the normal gametes. The resulting offspring will be in this form. These two daughter, this will give rise to daughter. So one of the X sex chromosome with colorblind gene is received from the father. Here also same. One sex chromosome with colorblind gene is received from father. Here, since mother is normal, Y will fuse with this both the sex X chromosome and will give rise to normal son. So in this case, all the daughters will be the carrier of the colorblindness, and all the son will be normal. In this case also, this daughter or the women will become colorblind only when the gene for colorblind is present in both the XX sex chromosome. So since one is colorblind, one X chromosome is carrying the gene for colorblind, but one X chromosome is normal. So in this case, both will be carrier, and all the son will also be normal. The second one is if this carrier female marries to the normal male, then in this case the gene will the sex chromosome will be in this form during gamete formation, and the possible offspring that may result from the intermarriage of the colorblind or carrier female with normal male is that there will be one carrier female, one colorblind male, one normal female, and one normal male. So this shows that there is 50% chances of female with carrier, 50% chances of male with colorblind, 50% chance of normal female, and 50% chances of normal male. So these are the possible offsprings. Now the next one is when a colorblind woman marries a normal man. In this case also, colorblind women means both the gene for colorblind will be present in both the sex chromosome. So these are the sex chromosome of the colorblind women, and this is the normal man. So during gamete formation, both these will occur and will fuse with this the normal male sex chromosome. So here, when these two cross with this is their possible offspring. There will be two daughter who will become carrier and two son who will become hemophilic. So the possible offspring that may result from this is that there is possibility that all the daughter may become the carrier of colorblind. They are not colorblind, but they are becoming the carrier. And all the son, there is possibility that all the son may result in colorblindness. So there is 100% chances of giving rise to colorblind female, and there is 100% chances of male that may arise that may result into the colorblind male. So this is about colorblindness.